In lesson 2, we define the derivative of a function as the instantaneous rate of change at a given point, which we said is the limiting value of the average rate of change in an interval. It is also a measure of the slope of the tangent line drawn at that particular point. All these are definitions of the derivative of a function. And we use the definition of the derivative of a function to calculate the derivative of a couple of functions. And I told you to remember those values. Now, in this lesson, we will develop some very simple rules so that we don't have to use that cumbersome method of taking the limiting value of the average rate of change. Now, you know that the rate of change of 7.5t, you remember this, don't you? The rate of change of 7.5t with respect to t is 7.5. That means the derivative of y equal to 7.5t is 7.5. We say like this, d by dt of 7.5t is 7.5. What does that mean? It means the derivative of the function 7.5t with respect to t is 7.5. Similarly, the derivative of 2x with respect to x is 2. The rate of change of this quantity will be 2. And how do you write that in this format? We say d by dx of 2x equal to 2. The derivative of 2x with respect to x is 2. In other words, if y equal to 2x, then dy by dx will be 2, or y prime will be equal to 2. Again, the derivative of 5p with respect to p is 5, or d by dp of 5p, the derivative of 5p with respect to p equal 5. In the first case, the independent variable is t. We take the derivative with respect to t. In the second case, the independent variable is x. We take the derivative with respect to x. In the third case, the independent variable is p. We take the derivative with respect to p. So, you know now how to find the derivative of simple functions like this. Tell me, what is the derivative of a constant? Say y equal to 5. Now, by its very nature, a constant does not change. Therefore, what is its rate of change? Well, if a constant doesn't change, its rate of change is 0. Therefore, the derivative of a constant is 0. So we say if a is a constant, then d by dx of a equal to 0. The derivative of a with respect to x equal to 0. In fact, the derivative of a constant with respect to any independent variable is 0. d by dt of a equal to 0. Is that right? All right. What is the derivative of 2x plus 10 with respect to x? Well, we can find the derivative of each of these. What is the derivative of 2x with respect to x? It is 2. The derivative of 10 with respect to x is 0. Therefore, we say the derivative of 2x with respect to x is 2. The derivative of 10 with respect to x is 0. Therefore, the derivative of 2x plus 10 equal to 2. You see, earlier we said the derivative of y equal to 2x equal to 2. And now the derivative of 2x plus 10 also equal to 2. That means a constant added to a function does not change its derivative. Is that right? Okay. We will now look at a simple rule that we can actually use to find the derivative of many simple forms of functions. That is called the power rule for the derivative. Now, you remember in lesson 2 we found the derivative of this function by taking the limiting value of its average rate of change. And we found that the derivative is 4x plus 5. We will now develop a rule so that we can find the derivative of such functions much more easily. And that rule is called the power rule. And what is the power rule? I'm going to define that for you. The power rule says if you have a function of the form y equal to ax to the power of n, a is the coefficient of x, n is its power. So if the function is of the form y equal to ax to the power of n, look at this, ax to the power of n, a is 2, n is 2. How about here? Ax to the power of 1. So all these are in this form. Then the derivative of such a function, the derivative of ax to the power of n with respect to x will be a times n, multiply the coefficient with the power, a times n times x to the power of n minus 1. The derivative will contain the power 1 less than the function. So once again, derivative of ax to the power of n is an times x to the power of n minus 1. Now let's apply it right here. Derivative of 2x squared, an, 2 times 2 is 4, x to the power of 2 minus 1 is 4x. And the derivative of 5x, you can apply the same rule. 5x to the power of 1, 5 times 1 is 5, times x to the power of 1 minus 1. What is x to the power of 1 minus 1? X to the power of 0, that is 1. So the derivative of 5x is 5, and so on. So the derivative of 2x squared is 2 times 2 times x to the power of 2 minus 1, that is 4x. The derivative of 5x equal to 5. The derivative of negative 3 equal to 0. Therefore, the derivative of the function 2x squared plus 5x minus 3 is 4x plus 5, which is the same result we got in the last lesson. Alright, let's now use the power rule to find the derivative of this function. Y equal to 10x to the power of 8 minus 7x cubed plus 5x squared minus 7x plus 3. We will take each term and use the power rule to find the derivative. Tell me, what is the derivative of 10x to the power of 8? It will be 10 times 8, 80, times x to the power of 8 minus 1, that is 7. 80 x to the power of 7. Alright, what is the derivative of negative 7x to the power of 3? A is negative 7, n is 3, so it is negative 7 times 3, that is negative 21. X to the power 3 minus 1 is x squared. What is the derivative of 5x squared? Is 5 times 2 is 10, times x to the power of 2 minus 1 is x to the power of 1. And of course the derivative of negative 7x is negative 7. And the derivative of 3 is 0. We have now the derivatives of each of these terms. So tell me, what is the derivative of this function? Or what is dy by dx? dy by dx is 80x to the power of 7 minus 21x squared plus 10x minus 7, and that is the derivative of that function. A very simple way to find the derivative. So that power rule is very useful, and practice it. Let us now find the derivative of y equal to square root of x. We actually did that in lesson 2, is that right? We did it. we found the derivative of square root x as 1 over 2 square root of x. Do you remember that one? Okay, we can use the power rule to do this. How? Can you write square root of x using a power? What is square root of x as x raised to the power of what? Well, y equal to square root of x is the same as x to the power of 1/2. So, in this case, a equal to 1, n equal to 1/2, you can use the power rule. So you have dy by dx equal to 1 multiplied by 1/2, a times n, times x to the power of n minus 1, 1/2 minus 1. And that will be, this is your 1/2. And what is 1/2 minus 1? 1/2 minus 1 is negative 1/2. So that will be 1/2 times x to the power of negative 1/2. And remember, a negative power can be made positive by taking the quantity to the denominator. So x to the power of negative 1/2 is the same as 1 over x to the power of 1/2. So this becomes 1 over 2 x to the negative half will become x to the power of positive 1/2 on the denominator. And now we write x to the power of 1/2 as square root of x. So the result is 1 over 2 square root of x. The same result we obtained by using the limiting value of its average rate of change. Alright, so the derivative of square root x with respect to x is 1 over 2 square root of x. Similarly, the derivative of square root t with respect to t, d by dt of square root t is 1 over 2 square root t. Very important result. Let's find the derivative of y equal to 1 over x using the power rule, which means you need to write 1 over x using some power of x. What is 1 over x as x to the power of something? Well, y equal to 1 over x is the same as x to the power of negative 1. Is that right? And now your a equal to 1, n equal to negative 1, we can use the power rule as an x to the power of n minus 1. dy by dx is a times n, 1 times negative 1, times x to the power of n minus 1, negative 1 minus 1. That will be negative 1, that will be negative 1, x to the power of negative 2. And now we write this x to the power of negative 2 using positive power as 1 over x to the power of 2. So that will be negative 1 divided by x to the power of 2. A very important result. The derivative of 1 over x with respect to x is negative 1 over x squared. d by dx of 1 over x is negative 1 over x squared. Similarly, I can say d by dp of 1 over p is negative 1 over p squared. Or d by dt of 1 over t is negative 1 over t squared, and so on. Now tell me, what is the value of d by dx of a over x? d by dx of a over x. The derivative of a over x will be negative a over x squared. That's right. That'll be negative a over x squared. A very important result. We will be using it many times as we go on. We will now summarize some of the derivatives that we have already discussed and add to that list some standard